In section 9.2, we're going to learn about linear regression. If it turns out that the linear correlation of a paired dataset is significant, the next step is to find the equation of the line that best models the data, known as the regression line. This line can then be used to predict the value of the response variable for any value of the explanatory variable. So it becomes a tool to make predictions based on data, which is used in so many different areas of our lives. If you are interested in learning how to find the equation of this line by hand, I'm going to refer you to your textbook because, once again, the formula for doing so is very complex and it's much easier to use technology. So I've modified example 2 from this section slightly. They want us to use Excel to find the equation of the regression line for the Old Faithful data used in section 9.1. And then I added on, use the equation for the regression line to predict the time between eruptions if the duration of an eruption is first 4 minutes, then 5 minutes. It's very easy for Excel to find the best trend line to fit the data. To do this, you're going to click on your chart once you've made it. And again, we're just using the same data as before, so I've already got that information loaded. You're going to go to Chart Design and add Chart Element. You'll see Trend Line as a choice. And rather than go straight to linear, go to More Trend Line Options. That'll bring up this formatting area, and you want to be on the 3 bars. Choose the linear trend line, and you're going to see now that there is a line added to my points. And this is the best line of best fit. It will be the most accurate tool for predicting based on this data set. Now, you should go down to the bottom of the format window pane and click on Display Equation on Chart. Now, as usual, Excel does it super tiny. So I'm going to grab that equation, move it, click inside of it, highlight all the text, go to Home, and increase the text size. And what you see here is the equation of a line. Now, for those of you who don't remember your high school algebra, the equation of a line always will have x as the variable. The slope is the number in front. And because the slope is positive, our trend line is trending up. If our trend line is trending down, it would be negative. And the other value is the y-intercept. If you trace this line all the way back, it's predicting that you would cross the y-axis at 33.683. Now, you can also generate the slope and the intercept of this equation in another way. I'm going to go to an empty cell and create a spot for slope and one for the y-intercept. In the cell next to the word slope, I'm going to hit equal sign, type slope, and you'll see it'll come up as a choice. And notice you have to highlight your y's, comma, your x's. So y's first, because slope is change in y divided by change in x, comma, highlight your x's. And it'll return the value that you see rounded on the graph. To get the y-intercept, you type equals intercept. You leave off the y portion. And again, you're going to need to highlight the y's first, comma, the x's. Now, the reason that you would want to do that outside of the graph is to help you answer the second part of this question. So let's go back to our original question. Now that we have a model that relates the explanatory variable and the response variable, we can make predictions. So in part B, we're asked to predict the time between the eruptions if the duration of an eruption of Old Faithful is 4 minutes long. So that 4 minutes represents the explanatory variable, which is the x. And since I have an equation, I can now substitute that x into that equation. So we're going to have y equals 12.481 times 4 plus 33.683. Now you pick up a calculator and get a value. The value turns out to be 83.607. And when I give my final answer, I'm going to round that to only one decimal place because our data set had 0 decimal places, and that is measured in minutes. So I would need to wait approximately 84 minutes for the next eruption to take place. And if you compare that to the table of values, that does seem to fit the pattern that's happening. To calculate for 5 minutes, which was above the values that were in our data set originally, I would do the same process, substituting 5 in for x. My final rounded answer is approximately 96.1 minutes. Now let's go and see how you can do this in Excel. So I'm going to set up a small chart here, and I've got the headings. Duration was the x value, the time between eruptions was the y value. I'm going to click in the box below the time between. I'm going to type equal sign, and I'm going to put in the formula for the equation of the line. So remember, the line has the slope and then times x. My slope is stored over here. For me, it's cell E21. I'm just going to click on that, and you can see it's added it to my formula. Now I'm going to hit the times sign, which is the asterisk. Hit Shift and 8. And then I'm going to click the box next to it. This is where my x value will be. So I don't want to type an x there. I want to click on the box in the x column of my table here. Then I'm going to hit plus, and the last part of the formula is the y-intercept, which I have stored in this cell. And again, you can see Excel puts the cell name into my formula. I'm going to hit enter. Now, if I put a duration in this x spot, say 4 minutes, I get the same answer we did by hand, and I get more decimal places of accuracy because Excel is working with all of these decimals. We worked with the rounded ones because simply it just gets too difficult to have to type all those digits correctly. So this is in fact a more accurate answer. For 5 minutes, I just switch my duration to 5 and it updates the time between. I do need to give you one word of caution here. When you are using a line of best fit to make predictions, lines do extend infinitely in both directions. So I can type in a duration for an eruption like -1, and the line will make a prediction. However, that x value does not make sense and should not be one that I use. It doesn't make sense in the context of the situation because the eruption duration is not going to be -1 minutes. We try to always make sure when we're using a line of best fit to make predictions that we only do so for x values that are close to the original data set. So my original data set has numbers from 1.8 up to 4.63. So I would not want to go ahead and start predicting for really large numbers either. I can predict that if there was a 10-minute eruption, what the length of time between would be. But again, that x value should not be considered because it's not close in proximity to the original data set. So this is how you're going to use Excel to be able to make predictions based on a line of best fit.